My dear students of Btech second year, I am Dr. Rohit Parsai, Associate Professor of Mathematics in Engineering Science Humanity Department at Chamini Devi Group of Institution Indore. I want to teach you Lecture 1 on Mathematics 3 Unit 1 as Module 1, Introduction and Basic Tool of Solution of Polynomial and Transcendental Equations. With this, we also study the bisection method with example. So, first of all, we understand the introduction and the basic tools. So, in this unit or in this module, we will discuss one of the most basic problems in numerical analysis. The problem is called a root finding problem and consists of finding value of the variable x as real that satisfy the equation f(x) equal to 0 for a given function f. So let f be a real valued function of a real variable, any real number alpha for which f(x) equal to 0, that is this equation is satisfied, is called a root of that equation or 0 of f. So we shall confine our discussion to locate only the real roots of f of x. So we shall consider the problem of numerical computation of the real roots of the given equation f(x) equal to 0, which may be algebraic or transcendental. All methods for numerical solution of algebraic and transcendental equation discussed here and the next coming two lectures will consist of two steps. First step is about the location of the roots, that is, a rough approximation value of the roots are obtained as initial approximation to a root. Then the second step consists of methods which improve the rough value of each root. A method for improvement of the value of a root at a second step usually involves a process of successive approximation of iteration. For the first step, we need the following theorem. So, f of x is continuous in the closed interval a comma b, and f of a are of opposite signs. Then there is at least one real root alpha of the equation f(x) equal to 0 such that alpha lies between a and b. So let me understand through this lecture 1. First method is we called bisection method, or it is to be generated by Bolzano scientists, so that it is called Bolzano method. In this method we find an interval in which the root lies and that there is no other root in that interval. Then we keep on a narrowing down the interval to half at each successive iteration. So now we proceed as follows. First is find an interval say I in which the root of f(x) equal to 0 lies and that there is no other root in I. Then we come to the second step as bisect the interval, or by taking the average of these two values, you can say that, and compute f of x. If mod of f of x is less than the desired accuracy, then it is the root of f(x) equal to 0. Otherwise, check the sign of f(x). If sine of f of x equal to sine of f of x2, then root lies in the interval x1 comma x, and if they are of opposite sign, then the root lies in the interval x comma x2. Change x to x2 or x1 accordingly. We may test sine of f of x into f of x2 for same sign or opposite signs. Check the length of the interval mod of x1 minus x2. If an accuracy of say 2 decimal places is required, then stop the process when the length of the interval is 0.005 or less. So we may take the middle value x is x1 plus x2 upon 2 as the root of fx equal to 0. The convergence of this method is very slow in the beginning. That is, we will get very slowly the answer at the beginning. So let us we understand this method, or this method is well understood by the following example. Find the positive root of the equation x cube plus 4x square minus 10 equal to 0. By bisection measure, correct to 2 places of decimal. So first of all, we write the given equation. It may be either algebraic or transcendental. Let us find the location of the positive roots. That is x equal to, suppose we take 0, we will find the value of f of x at x equal to 0. On putting this first term 0, second term 0, you will get minus 10, and then you will find the value of f of x. Find the value of f of x. Already you have find the sign is negative right here. Then you find the value at x equal to 1. On putting this time, you will get minus of 5. That is the sign of fx is minus. Then you put 2. That is, you are getting 14. There the sign is plus. When you are getting minus plus or plus minus, now if you put higher values, then the sign is positive. It means we have to take the range of solution is 1, 2. There is only one positive root and it lies between 1 and 2. So let x1 equal to 1, x2 equal to 2. At x equal to x1, f of x is negative, and at x equal to 2, f of x is positive. So now we examine the sign of f of x at x equal to by taking the average of these two values. 1 plus 2 upon 2 is 1.5, and check whether the root lies in the interval 1 comma 1.5 or 1.5 comma 2, because you are breaking this interval into two sub intervals. One part is 1 and 1.5, and second part is 1.5 and 2, because 1.5 lies between 1 and 2. That's why you are having these two options here. Let us show the computation in the table below. We will continue this process successfully. We explain by in tabular forms. As the first column half, you are having iterations. Iteration means how much time in which you will repeat this method. So first time for this one, second time 2, third time 3, 4, 5, 6, 7 and 8 here. So for this we have already calculated this sign of this. The value of f of x is 2.375. That is the sign of fx, and f of x2 you will find is this product is plus, and we have x1 equal to 1 and x2 is already, you know, that 1.5. Now you proceed this, you will again break this, and you will find the value is 1.25 minus, again you take the average of these values, you will find this value, and the sign of this minus 1.795, that is sign is negative. So that's why now you have this value in between. X1 becomes 1.25 and x2 become 1.5 is as it is. Now you proceed ahead by taking again the mean of these two values. So this comes out to be the mean of these two values 1.375. Then again you find the value of the functions, and you see the sign is plus, and then here already you are having 1.25 and the x2 is shifted to 1.37. so like this you will continue in this process as long as you are not getting the two consecutively same values here. So therefore now you will conclude that we see that there you will find the difference of the last two values is 0.004. so we can choose the root as by taking the mean of the last two values of x1 and x2 as 1.367 plus 1.371 and divided by 2, that is bisecting by this. So the value is 1.369. Thank you very much.